In this video, we will talk about how to break forces or a force vector into its components. Well, first of all, why do we need to break down a force vector to its components? So the answer is we need to break a force vector into its components because it is much easier to add vectors that lie on the same axis. Let's say if we have this particular vector here and this vector here. If we want to add these two vectors directly, of course we can use the tip to tail. But then there are 10 of them or more. It is now very long and will give you so much error. That's why we need to break them up into its components, because after we break them up to its components, it will look something like this. To the x, we have this smaller x component, and this one we have, in terms of x, we have this one going here, while in terms of y, we have all of them going up. And if this is now the setup, it is now easy to add them because they lie on the same axis now. So if we add all the forces in the y, we'll get this one and this one, right? And if we add all forces in the x, we'll get this one and this one going to the opposite. And if we already have the vectors perpendicular to each other, we can use the idea of tip to tail wherever it goes, think like that, and solve for the resultant by means of Pythagorean theorem. So this is the sum of all the forces in the x and sum of all the forces in the y, and by the Pythagorean theorem, hypotenuse squared is equal to sum of the forces in the x this side squared plus sum of the forces in the y squared this side, since this is perpendicular to each other. So now, why do we need to break down the forces into its components? We need to break force into its components so that it is easier for them to be added. So just like what we did here. After we break this down, here's its x component, this one, here's its x components, and these two are the y components of this. Then finally, this one. After we manage to get the vertical component and horizontal component, we've got the vectors perpendicular to each other. And since they are perpendicular to each other, by the tip to tail in adding vectors, we can now take advantage of the Pythagorean theorem formed by the right triangle of this vertical component and horizontal component. So that is why we need to break down the force. So now, another thing that we're going to talk about is how to break down the force. So we've answered why, and now we're going to move to how. So there is actually two cases. So when the vector or the force is given with an angle, and when it is given with the slope. Yeah, how much in the x and how much in the y, right? Now, let's talk about this first case. When we're given with the angle, to find the components, we just have to use some trigonometry here. The SOHCAHTOA specifically. Sine over hypotenuse. For sine, it is opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. And For tangent, it is opposite over adjacent. Since the components of the vector here is something like that, and like this one, we can form the triangle by moving this one, the component, into this one to get this resultant. Alright? Diba kay ang kuan is we need the tip to tail. So tip to tail and then this tip to tail. Alright? And with that, we've formed the right triangle that represent this f of x, or the component of this force with respect to the x-axis, and this force with respect to the y-axis. So with that, if we take sine of theta, you get Fy, or the opposite side, over the hypotenuse, which is F. So Fy over F. And thus, if we solve for Fy by multiplying both sides by F, you'll get F sine theta. Ba? And now for Fx, just take cosine of theta, and then the adjacent side, which is Fx, over F, which is the hypotenuse. So Fx over F. Solving for Fx, multiply both sides by F, you'll get F cosine theta. So this is how we solve for the components of the force when we're given with the angle. If we're given with the slope, of course it has it has a component in vertical and also in horizontal. All we need to know, if we need the vertical component, or the p of y here, we just have to get first the value of the hypotenuse formed by the slope. So with that, the hypotenuse is x squared plus y squared by Pythagorean theorem, right? And so, if we need the vertical component, we just have to use this. P of y is equal to the vertical from the slope times the magnitude p all over the hypotenuse. Alright? Then for p of x, we now use the horizontal side. So this, the run, so that's x, times again the magnitude all over the hypotenuse. Ano lang. For instance, if we have this, let's say this is 4 and then 3. Its hypotenuse is 3 squared plus 4 squared. That's 9 plus 16 is 25, and the square root of 25 is 5. So that's 345 slope. And let's say the force is 25. This is the x component, so f of x. And this is f of y. So if we need f of x, so again, we use this. 3 times how much? The magnitude is 25 all over the hypotenuse. So 3/5 of 25. Ano lang. Then for f of y, 4/5 or 4 times the magnitude all over the hypotenuse. So that's how we solve or break down a force vector when we're given with the slope or the angles. So now, to fully understand this, let's try this particular example. This one. So our goal here is to find the x and y components of each of these forces. So we have F equals 390 pound given with this direction. So you can see it is in slope form. And then we have T, which is 400 pounds, 40 degrees from the x-axis, and P, which is 300 pounds, 30 degrees below the x-axis as well. So now, let's begin with this force, 390. So again, our first step is, when we're given with slope, is to find the hypotenuse. So what's the hypotenuse here? By Pythagorean theorem, it's just 5 squared plus 12 squared. And that's gonna be 144 plus 25 is 169. And the square root of 169 is 13. Right? And we know that this is the x component and this is the y component of this force F. So this is f of x and this is f of y. Now, for f of x, you know that f equals 390. For f of x, again, we will use this 5, diba? The x component, 5 times the magnitude, which is 390. 5 times 390 all over the hypotenuse. Right? So 13. And then, one last thing we need to consider is its direction. Diba? Muna siya lagmitan masayop or makuha error kay malimtan ang direction. If we assume that positive is going to the right, and we know here that our force is going towards left, so automatically this f of x, this force that goes to the left, will then be negative. So this is now the component of this force with respect to the x-axis or the horizontal component. Now for f of y, it's this 12 times the magnitude 390 all over 13. And what? It's going upwards. Since we assume that going upwards is positive, this is now the answer. This is now the magnitude of the f of x and f of y. Now for the second part, the green, we have t equals 400 pounds. As you can see, we're given with an angle. So we write the components. This is ty and this is tx. So again, this ty is equal to this. These two are equal. And so we form a triangle with 40 degrees as its angle. So if we want t of x here is the adjacent. So when you have adjacent, you just have to multiply the magnitude with the cosine of the angle, whatever the cosine. Just take note where the t of y and t of x lies. Since it lies adjacent to our angle, we multiply the cosine of the angle to the magnitude. But if, for example, t of x lies below, or the opposite the angle, don't forget that it's now sine. We use now the sine, not the cosine. Ano lang. So since t of x is adjacent to 40, t of x is just 400 cosine of 40. And then, its direction. It's heading towards left, diba? This one. So it's negative. And then t of y is, here this is t of y. This is t of y. This one, t of x, is this one. This is t of y. It's opposite, so it's sine. So t of y is 400 sine of angle. But then, again, it's heading downwards. This one. So it's negative. So this is now our second answer. And finally, for the force P, since that's also an angle, we're given with the angle as direction. So we have no problem about that. P of x, this one, here, it's adjacent. So it's just 300 cosine of 30. And it's heading towards right. Then for P of y is going down. So it's negative 300 sine of 30. So this is how we solve this particular problem. And that's how you break down a force into its horizontal and vertical components. Once again, thank you so much for watching, and subscribe, like, and share this video to your friends. That's all. Peace out.